Hello guys, today I want to make a review of 3 bugs from Centrifuge contest on Sherlock. Let's start with something simple. First bug is pretty straightforward. Imagine we have a function on update. This function calls another contract function, gateway with batch. As we can see, with batch is a payable function and requires some message value to pay for execution fees. However, since an update is not payable, no Ethereum is forwarded. In scenarios where fees are required, this causes the transaction to revert. The fix is pretty easy. Here is how the code should be updated. This one is more complex, so I'll extract only the necessary parts. Users deposit and withdraw funds in 2 steps. First they submit a request, and only then the request is executed and user receives funds. Here we're interested in 2 mappings that's involved in this process. First one is pending deposits. It tracks global pending deposits for a specific pool and asset. Second one is deposit request. It tracks each request individually for each user. With that in mind, let's investigate where the issue appears. When a deposit is approved, the global pending amount is reduced like this. However, for user deposit requests, the logic is different. The issue is that muldiff function rounds down by default. If rounding occurs, the deducted amount will be smaller than approved assets amount. Later, when processing a deposit, the following logic is used. Because the user's pending value may have been reduced less than the global pending amount, amounts can become greater than pending total. This leads to an underflow and makes it impossible to properly process or execute pending deposits, effectively causing a permanent denial of service. Now let's get to the fix. It's pretty trivial. We must ensure that the subtracted value never exceeds the global pending amount. This strictly guarantees that subtraction cannot exceed the global pending value, preventing underflow and denial of service. Last one is particularly interesting, so I'll explain it conceptually rather than diving into implementation details. Imagine a bridge that allows messages to be executed across multiple chains. For example, a message is executed on Ethereum chain and then is relayed and then executed on base chain. Now imagine that this message consumes 28 million gas. On Ethereum this is fine, because blocks can go up to 60 million gas. But on base, however, there is 25 million gas limit per transaction. As a result, the message executes successfully on Ethereum. It gets relayed to base. On base, the transaction can never be executed due to gas limits. This leads to a cross-chain desynchronization, which is especially dangerous because one of the core purposes of cross-chain system is to keep states synchronized across chains. To mitigate such issue, introduce a maximum gas limit, or message counts complexity limit, or batched messages, to ensure that every message is executable on all supported chains. Thanks everyone for watching, and I hope you'll be able to find similar bugs in your future contests.